Hello everyone, super happy to be here with you. So my name is Edouard. I'm the CTO Co-Founder of Kili Technology. And we're going to speak about data. So as you all know, AI is made of three pillars. Data, compute, and algorithms. At Kili, we supply the data pillar. So our job is to create frontier data for frontier AI. And very concretely, what we do is that we label data, we annotate data for three populations, European and US governments. So for instance, we work for the Department of Defense in the US. We work for the people building those large language models. So for instance, we provide the annotations used by Mistral to train their models for the RLHF and the supervised fine-tuning part. And we also label data for a bunch of Fortune 500 companies. How do we do this? Three things. We provide three things. We provide the workforce. We provide a platform, a software platform, and we provide project managers. The workforce, we are able to source almost any kind of labelers, people labeling. These people can be PhDs, doctors, lawyers, and so on and so forth. We provide the platform, so both the UI and the API used to orchestrate the labeling of high-quality data. And we provide project managers who are machine learning engineers specialized with an expertise on data labeling and on aligning models and safety of models. So indeed, large language models need a lot of data, massive amount of data, for the pre-training, for the alignment, and for their evaluation. Just to give you an example, Llama 3 has been pre-trained on more than 15 trillion tokens, and its alignment data contains more than 10 million human annotated examples. And at Kili, we provide the data, the annotation used to align those models and to evaluate them. So for instance, at Mistral or at Meta. So for those ones among us in the machine learning community who are building those large language models, so for those ones who are working for a Mistral, for a Meta, etc., the race for better AI is for better AI through better data is just starting. To give you an example, at XAI, so the company of Twitter, more than half of the technical staff is made of AI tutors, so people being in charge of data labeling projects. Two reasons for that. The first one is that high-quality data is scarce, so it's difficult to find high-quality data. And the second reason is that creating new high-quality data is hard. And two reasons for that. For supervised fine-tuning, you need labelers with advanced writing skills, so very good at writing. And for the RLHF part, you need a lot of volume. So you need to be able to scale your labeling operations. And so at Kili, we want high-quality data available for everyone. And why that? Because we believe that the future of AI depends on three things. The availability of evaluation data for everyone, the availability of fine-tuning data for everyone, and the availability of high-quality data for everyone. And so now we are going to deep dive on those three needs. First one is evaluation data. So you can only improve what you measure. And building a solid evaluation is the starting point of any large language model, system, or product. And if you forget to do it, you just get this. So remember the Gemini scandal, where you have Asian Nazis, for instance. So evaluation is difficult, and there are several challenges when it comes to evaluation. The first one is metrics. With Gen AI, the usual metrics that we use in machine learning don't work. So let's take, for instance, the Rouge score, used usually to assess the quality of summarization. The Rouge score is not working when we do abstractive summarization or for dialogue. The second difficulty when it comes to evaluation is the benchmarks. Benchmarks and benchmark datasets like MMLU, which is made of thousands of multiple choice questions on physics, philosophy, mathematics. Those benchmarks, they don't make sense for LLMs unless the goal of your large language model is to pass a school exam. And also, but they are often contaminated, so meaning that some information of those evaluation datasets are in the training sets. And so the question is how to overcome those challenges. So the first thing that we do at Kili is doing red teaming. So red teaming involves internally using large language models to test them and to assess their limits. For instance, we might want to understand how a large language model behaves when we change the language, when we switch from one language to another during the conversation. And red teaming is typically what Google probably forgot or didn't do enough with the Gemini model. The second thing that we do is creating evaluation datasets. So namely, we create collections of prompts, context, and expected answer, expected output, that are used by the machine learning engineers to guide them when doing their prompt engineering or the selection of the models or the fine-tuning of the models. Second need, we saw the need for evaluation data. The second one is the need for fine-tuning data. Indeed, AI is only as good as the data it has used to be trained on. And thus, what it means is that the future of AI really depends on the availability of frontier data, so the ability to create the most cutting-edge data sets relevant to specific use cases and industries. Of course, for the majority of us in the machine learning community, we can already extract a lot of value from large language models with prompting. And fine-tuning is not needed. But sometimes the time comes when the accuracy of the large language models, the GPT-4, the Llama, and so on and so forth, is not enough. So the accuracy is not enough on your use case, or the latency of those models is too long, or the cost is too high. And so in this case, it makes sense to fine-tune them. To take an example, DaVinci is a company creating a copilot for IP professionals to help them draft patent in half of the time. And so the product is a Word add-in, a bit like GitHub Copilot, but for IP professionals, for IP attorneys. And so the DaVinci team tried to use GPT-4 to power this add-in, but the time, even the performance was good, it was too slow. And so by using a smaller but fine-tuned model, they managed to get better performances for a much lower latency. And so with precise fine-tuning, you can improve the accuracy, decrease the latency, and decrease the cost, and thus improve your competitive advantage. Another example, RAG, so it's a retrieval augmented generation. It's a way to inject knowledge in large language models very easily. And for RAG, the biggest source of error is the quality of the indexing of the retrieval system. And by labeling the retrieval system, you can improve it to find the relevant chunks. And we helped insurance companies to move the accuracy of their RAG stack from 35% to 90% with some labeling. And so at Kili, we create those examples for, so I said, for the supervised fine-tuning, the RLHF, the RAG, on text, on image, on video, and in many domains, math, programming, legal, etc. Last, high-quality data. As we all know, AI is garbage in, garbage out, so AI quality is super important. Andrei Karpathy, who was previously the head of AI at Tesla, said, even after 4 years, I haven't solved the labeling workflows. Because indeed, operating high-quality data labeling at scale is difficult. And why? Because to be sure of the quality of the data, you need a lot of steps, like sourcing the right labelers, training them, assigning them the right tasks, controlling the task, controlling the quality, cleaning the data, building consensus. So it's quite difficult. As said, we work for several large language model providers, people being large language models, and those people, they have several challenges. So the first one is that it's difficult for them to get good human feedback from their users, because the feedback they are interested in is the helpfulness and the harmlessness, and this is something that they cannot get from their users. The second thing is that managing labeling projects is not their differentiator, so it's a misfocus for the tech team. The third thing is that sourcing expert labelers is difficult. It's not easy to get Rust programmers that are willing to label. And scaling labeling project is also a pain. And so what we did what we do for them is we source them a project manager, so expert in AI and the alignment and the safety of the models. We provide them a solution engineer to link their model with our labeling API. 2 teams of labelers to do the RLHF and the supervised fine-tuning. A specialized workforce, and a labeling tool to orchestrate those labeling needs. And so with that, we managed to create high-quality data at scale, customized to their needs, and for a very competitive price. So to conclude, the quality of Gen AI largely depends on the availability of fine-tuning high-quality custom data. And at Kili, we build this data foundry to create an area of abundant data for AI. Thank you.